Okay, Year 12, welcome back to another video. We're going to continue looking at trigonometry. Today we're talking about angles of elevation and depression. So these are terms that are often used when describing a situation where we're concerned with either what the distance of something is or how big an angle is between things. And it's used to describe how things are relatively positioned to each other, whether they are above or whether they are below. Okay, so the two terms are always referring from the horizontal and whether or not we're going up from the horizontal or whether we're looking down from the horizontal. Okay, so the first one, the angle of elevation, we can think of is we're on the ground and we're looking up at something. Okay, so the ground represents the horizontal. The angle goes up from the horizontal, and that's going to be an angle of elevation. So here is an example where we're looking at a little bird in the sky. Here's a little bird, and we're looking up from the ground. So that angle is an angle of elevation. Okay, the angle of depression is also the angle from the horizontal, except looking downwards this time. So if we're on top of a cliff and we're looking down at a boat on the sea, we would be looking down from the horizontal. And that angle is the space between a sort of imaginary horizontal line that's parallel with the ground or the sea, and then the angle that is created to your line of vision towards that object, whatever it is. So we just need to remember that it's always from the horizontal, either up or down, depending on whether it's elevation or depression. Okay, what we don't want to do is get it confused with the angle on the inside. So it's definitely not this angle here. Okay, that creates a right angle triangle like that. Okay, so that is not the angle of depression. It's always the angle between the horizontal down, not the vertical up. So always make sure it's always horizontal, up or down, depending on if it's elevation or depression. Okay, so let's look at a couple of examples here. Here we have one here. So it's the angle of depression of a ship at sea on top of a 60-meter vertical cliff is 4 degrees and 54 minutes. And we need to calculate the distance of the ship from the base of the cliff. And we've got a little diagram here. That's very fortunate that we're given a diagram. So we have an angle that's in here, 4 degrees and 54 minutes. And we have a length here, 60, and we need to find the distance from the ship to the of the ship from the base of the cliff. So what we want to do on our diagram here is we're going to put a value of x, and that's going to tell us which unknown that we're trying to find. So it's the distance from the ship to the base. So I'm going to put x here, and that way it reminds me that is what I'm trying to find there. So put that in first in the diagram, and then we're going to think, how are we going to work out what x is? Now, there are a number of different ways that we can do this, and I think the easiest way to do it is using parallel line laws. So remember that this one here and this imaginary line here are parallel, okay? They're both perfectly horizontal lines, which make parallel lines. And we know that alternate angles, okay, are equal in parallel lines. So an alternate angle is one that causes a sort of Z shape. So that means that this angle here is also 4 degrees and 54 minutes. Okay, so what we've done is we've used parallel lines to show that those two angles, the angle of depression from the cliff and then the angle on the inside near the boat, are going to be equal. So now I can set up a trigonometric equation using that new angles position that's going to relate 60 and x together. So from that angle down here near the boat, I have the opposite side, which is 60, and I have the adjacent side, which is x. So I get an equation. So if it's opposite and adjacent, I'm going to use tan. So it's going to be tan brackets 4 degrees and 54 seconds equals opposite, which is 60, over x. Okay, and now I just need to rearrange to get x on its own, but we have a problem. We've got x on the denominator this time. So what we're going to do is we're going to do some cross multiplying. We're going to multiply both sides by x, and at the same time divide both sides by tan 4 degrees 54 minutes. So we're going to swap the position of x and the tan, so it becomes x equals 60 over tan 4 degrees and 54 minutes. Okay, cross multiplying is what we call that, when the bottom of the fraction on one side goes to the top on the other, and the top from the other side goes to the bottom on the other side of the equation. So now we have x on its own. We can put this in our calculator. So we get 60 over, and then it's going to be tan 4 degrees, press our degrees sign, and 54 minutes, press our degrees sign again, and then we can go equals. Okay, and then we have our value here. So it says to the nearest meter, so 699.86 to the nearest meter is going to be 700 meters, and we found our value of x here. All right, let's look at our next example. So a building is 40 meters high. Calculate the angle of elevation on top of the building from a point that is 36 meters from its base, correct to the nearest minute. Okay, so what do we notice here? Notice that we're given two side lengths, and we need to work out which is the angle that we're trying to find here. Which angle are we trying to find? So it's the angle of elevation of the top of the building from a point that is 36 meters from the base. So the angle that we're trying to find is this angle here, the angle of elevation from the point that is away from the building. So now that we've drawn our unknown in, we can set up an equation that will relate that unknown to the information that we do have. So from this angle, again, we have the opposite and we have the adjacent side. So opposite and adjacent means we're going to use tan. So it becomes tan of that angle that we don't know yet equals opposite, which is 40, over adjacent, which is 36. And now to get theta on its own, we need to get rid of this tan. We're going to move it across and make it inverse tan. So it becomes theta equals tan inverse 40 over 36. And now we can find out what theta is by going shift tan fraction 40, and then press arrow 36, press across, close the brackets, and we get our one here. Now it says to the nearest minute, so we click our minutes button, and we have 48 degrees, and then our seconds are 46, so it's above 30, it's going to round up. So we get 1 minute, and we just show one dash to show that. So our angle is 48, well, it should be 48, not 40, 48 degrees and 1 minute is our answer here. Okay, so good luck with those questions today. Let me know if you have any questions, and I'll see you in the next video.